welcome again, everybody. Our last session will be with Mr. Aleksander Velimirovic. He's a global key account manager from ABB. I think all of you know ABB Motors, ABB Switzerland. Mr. Aleksander came with extensive experience, 14 years experience in automation and drive technology, 4 years as a project engineer at Siemens. Then he switched to ABB as a product manager and 3 years in sales. And now he's global key account for ABB. So Mr. Aleksander, thanks a lot for giving us this opportunity to hear from you, and the screen is yours.
Thank you very much, Mr. Tadmi, for the introduction, and thank you everybody for your time and the opportunity to be presenting here on this virtual forum. Very pleased. Let me share my screen. Does everybody see my screen? Is it good?
Yes, all is so well and clear. Thank you.
Okay, perfectly. So today we will speak about the motor topics and challenges for motors in the grain milling application area for where you are the experts, and basically everybody's working there. And as you can see here on the picture, this is shortly an overview. We have many different types of applications, many different challenges, and many different requirements for the motors. And now I'm a little bit trying to share, to give you an insight, what is very important to think about, how to proceed, and how to make the right investments regarding motors and drive technologies. Here, if you speak about requirements, as we saw that there are many different applications. Here we have, as an example, fans, blowers, conveyors, extrusion machines, milling machines, cranes, and all require motors, basically, but not all motors can be used for all those applications. The motor needs to be selected, configured, and produced to match this requirement. And we are dividing here that at ABB in, I mean, we can summarize it with the word RISE, like R stands for requirements, E for infrastructure, S for standards, and E for environment. So let's speak about the term R. So here we speak about the torque, speed, duty type, and all the application requirements that we have. And as an example, we can go later on for the next slide. We have here a pump, and the pump, the torque requirements are different than for different applications. So we see that the torque, we see here the torque function of speed here, and we see that the torque is quadratic. So the torque is rising in quadratic shape regarding to the speed, and the this kind of usually with low speeds we generate very low power and low torque. And as an example, this application is very suitable for energy savings or variable speed control or such stuff to save a lot of energy. We can go later to this topic about energy savings. But we see also here the mechanical interface between the motors is on a aligned shaft. So there is also no stress for the bearings, no belt, or we can use standard bearings as an example. Then we have different applications like cranes. I mean, I'm sure that every factory has a crane or something like that, and maybe there are ship loaders, ship unloaders. Those motors, I mean, the load is always constant, the torque is constant, the motors need brakes. Often they are mounted outside, and they have to maybe have an encoder feedback or such stuff. So these are very, very important differentiators or things to think about when we are dimensioning or configuring a motor. So I go back to this slide again here. So as well, the duty type. So this duty type, as we saw, that we can connect the motor to VFD, variable frequency speed drives. We can connect the motor direct online, or we can use a soft starter or a star delta connection. And the duty type defines how the application is working. I mean, if we have S1 duty, that means like an extruder or a milling machine, which runs basically the whole day on the same amount of torque or same amount of power, then this is continuous duty, or we have variable duty like a crane. The crane is not operating all the time, but when he has to, he has a very high starting torque, and all those stuff needs to be considered if we are speaking about applicational requirements. As an example, also the bearing and shaft load. Everybody, I mean, in the mill, there are a lot of belt-driven application, as everybody knows, and belt-driven applications, or the motor connected to a belt, or and then to the load, that increases a huge stress for the bearing. So the bearing needs to be designed in a specific way to withstand this stress, and maybe you need a roller bearing or a different type of bearing to handle the radial load or the axial load or such stuff. So if you don't configure, as an example, if the shaft load is too high, then these can lead to very dangerous situations where the bearing can be damaged, and create a shutdown of this kind of particular application or machine, or even it can harm more stuff or create a dangerous situation. I will go explore a little bit this kind of topic later on if you are speaking about hazardous area motors. So then this infrastructure, this topic is also very important if we have to select a suitable motor which complies for the local supply voltages, local installation stuff. So maybe you have reactive power requirements. So then you have to use maybe a VFD converter to reduce this reactive power component, or some part of compensation equipment and other stuff. So if you have a limited installation regarding current or such stuff, then everything needs to be considered in this infrastructural point of view, that you're not installing a too big motor which can't be delivering the power that he's designed for. And then there is a topic of standards, and those standards are very important if it comes to energy efficiency. There are a huge area of standards which we can see here. Here is a map of the global efficiency standards or minimum requirements for each country, which have one in place, as an example. And Saudi Arabia has won the SASO certificate. So this certificate is required, for example, if we want to import those motors to Saudi Arabia, or somebody is buying motors from some other places like Switzerland or Germany, then the government is asking for these certificates for those motors to be imported there. Otherwise, they will stop at the border, and then the huge problems are starting, that the motor cannot be taken into operation. So many more all over the world. Basically, they're defining the minimum efficiency which is required for a specific motor to be installed and running in a different country. I mean, the older motors, if you have motors in stock, like you have both them for 5, 4, 2 or 3 years ago, then you are not binded to this obligation or to those standards. But as soon as you're taking those motors or you're importing those motors from other countries or you're buying them, then those standards need to be respected. As you see in Middle East Africa, there are not so many standards regarding energy efficiency. So basically, we can use here the i2 motors or even go further with lower efficiency motors. But this is not always the smartest thing to do. We will see that in a couple of slides. Then there are as well like cooling methods for the motor. Then we can see here there are different cooling methods. We have the IC37. This is an open circuit motor where you have to deliver the cool air and channel the hot air. Such motors are often used in production plants which have very high temperature environment, and they are taking the cool air from outside or somewhere else to cool down the motor. This can also be done with water cooling, as we can see here on the right part, the IC81 water cooled, or then we have motors which are self-ventilated or forced ventilated. This is just an example. Forced ventilation is used if you have an extruder as an example, and you are running the extruder with the nominal torque, but in half speed. So a self-ventilated motor at half speed is not generating enough cooling power because the fan is connected to the shaft and the shaft is not rotating at full speed. So the cooling power of a self-cooled motor is not enough maybe. If you have a constant torque application and you're running it at half speed or 20% of the speed in a continuous duty operation. So then you need a forced ventilator or a water-cooled motor where you can ensure a constant cooling of the motor. Then there are as well, if grain milling industries, they are often in a hazardous area because of dust. So then you have to select the proper motor for this specific installation place according to your requirement. Then we have a huge portfolio with dust certified motors which can be installed in those areas. There are different zones, but this topic is very huge and difficult, and it will fill a whole day about speaking regarding the explosive atmospheres and the whole certification and process for that one. So if you have such requirements, we are here, ABB as a motor expert and a hazardous area expert for motors, to support you in any questions. Here for the safe ATEX certification or hazardous area motors, there are many different standards. The most important one or the most common one is ICX, the global certificate. And our motors are by standard ICX certified, but then there's ATEX for Europe and like EA for South Africa, PESO, India. There are many different standards, or the ECASEX for United Arab Emirates. So there are many standards, and often you need support, and therefore there are the specialists which operate or are familiar with those standards and everything. So we are now coming back to this topic, why service is needed. Or one other thing is exactly this environment. to come back to the specification environment, like hazardous area or enclosure types and ambient conditions. So if you select a motor, if you buy a motor from stock, and you have maybe 50 or 60 degrees in your application, then this motor maybe will break down earlier or will not be able to deliver the required power because the standard motors are designed to be operating at 40 degrees Celsius environments, as an example. So why service is needed? This topic for motors, as an example. If we have here the motor performance over time and the costs it generates, if you are not doing a proper service, I mean, we have here at the beginning a huge investment for the motor when we are buying a new motor, as an example, and installing the motor and generating huge initial costs, as an example, in proportion of the total cost of the motor. And then the operation of a motor is quite easy, not so very demanding, but you have to do quite a lot. I mean, the service and maintenance needs to be performed properly according to your requirements. As an example, if you have a motor which is running at very high speed, you have to change and adapt your lubrication intervals. And lubrication is exactly also a topic. If you are speaking about lubrication, we had a huge, nice presentation in this morning about this topic, and ABB is using Synth. If you have the requirement that you have to use food safe grease for the motors, so the motors are delivered with food safe grease in the bearings and are lubricated with that bearing in the further process, we are using this Synth lubrication or grease for our motors, so that we ensure that this grease is well certified and good for your particular application. But this is also something, the motors are not coming by standard with a specific race, and this is also part of the application requirements, and very important. So if you have huge bearing forces, radial bearing and such stuff, high temperature, high speed, you have to adapt your lubrication intervals to avoid unexpected breakdowns. This is the traditional way how maintenance is working for motors. So you're doing it by a strict schedule according to your experience, manufacturer specifications and application requirements. So if you have high temperature environment, high dust and everything, you're doing you're doing the maintenance, you're shorten a little bit your intervals and everything, so that the motor has no breakdown. And if the motor fails, you have a production loss, you have a repair time, and you need maybe different resources to fix this motor, and this generates huge costs. So maintenance, proper maintenance of the motors is quite important. I mean, it's, if you have 10 machines or whatever, then yeah, it's not so critical. But I mean, every machine is very critical. But if you have a bottleneck or something like that, then there are other ways how to ensure a proper and safe operation of the motors with more measurements and everything. We will see that in a further presentation or a further slide in my presentation. So what are the aging factors of motors if you're speaking about service or motor lifetime? We have thermal aging. This is as I have spoken, as I have described before. So the motor, if you have a high ambient temperature application, maybe in a dryer or somewhere else, then this is causing additional stress and requires more specific and tighter maintenance schedules. And there is electrical stress as well. If you are not using, if you have bad, how to say, high voltage peaks on your plant, or very variable voltages, bad network quality. Bad network quality is also causing thermal and electrical stress, and the windings and everything needs to be, this is reducing the lifetime of the windings. So this is something which happens very slow, but the total lifetime of a motor, which could be the winding lifetime, which could be 20, 25 years, is reduced slowly by electrical stress. Then there is also ambient stress, maybe rain, salty environment or something like that. Then you need a motor which is prepared and well designed for such environment, and you need to do the proper maintenance and everything. And there is also mechanical stress. If as an example, belt driven applications, if you're not mounting the belt on the right place, if you have vibrations or other mechanical stress on the machine, this is damaging the bearings, the bearing flanges and everything, and the motor bearings can maybe have a failure before their expected designed lifetime. So the maintenance strategy needs to be adapted to those things. And well, I mean, we can support you, or the application for different applications, how to do it in a right way. And there is also some safety aspects. What I saw over the years as well, if you install a motor which is hazardous area proof for everything, and then you haven't selected the right bearing for a belt driven application example, you have ball bearings instead of roller bearings. And as an example, then the bearings are damaged very fast, and the damaged bearings, if the bearings have a breakdown, they can cause excessive heating and warming of everything, and maybe the shaft can break, or the motor can overheat, and you can create a risk which could be avoided by selecting and doing the proper engineering and selection of the motor. I mean, also bad lubrication, if you not lubricate the motor. So the ATEX motors which are installed in hazardous area needs to always to be very well serviced and maintained to ensure a safe and reliable operation. As well, the gaskets, if the sealings and gaskets are not tight anymore or broken or such stuff, then maybe dust can enter the terminal box, create heat, and create a risk which is not required and not wished. And maybe the motor cooling surfaces, we know that the dusty environment, there are particles, can be everywhere, and they can close the cooling surfaces and such stuff, and the motor can overheat and everything. So the maintenance, in addition to the normal application motors for hazardous area, it's much more important to ensure a safe and reliable operation. As we know, the costs as well, insufficient cooling generates more losses, unnecessary stops or breakdowns. Bad lubrication creates motor failures, and also production loss or whatever. So those topics need to be considered very well to ensure optimized production and put through or output of your factories. There is as well, I have spoken about the traditional ways how to do the maintenance or what is important with the motor technology and such stuff to avoid any failures and to ensure such good operation. But there are also new technologies like smart sensors, as we saw also in a previous presentation. There are many types of smart sensors and digital solutions which can help you. And in this case, we are looking at the motor, which is equipped with a motor ability smart sensor from ABB. With our very long history and knowledge of motors, we have designed a smart sensor which works like a fitness wristband for electrical motors. So all the necessary health parameters of the motors are measured, and the mounting is very easy. So as you can see, it's holding on the cooling surface, or you can clamp it there, or you can, with a special 2-component glue, you can adjust it on every motor. The important information what we need is the bearings, the motor size, power, and all those nameplate information that you can find there. And what is the smart sensor doing? The smart sensor is measuring and checking the bearing conditions by a very powerful and fast vibration measurement. And he's also measuring the cooling temperature, the cooling and the power output and the temperature of the motor, the rotor condition, because we have a field measuring device. He can measure also the electrical field and rotor condition, air gap condition, if the field is very unsymmetrical, and the noise as well. And with all those factors, I mean, this is a cloud-based service which we are providing. Those sensors are also available in ATEX, certified for hazardous area. And you can, if we know that the motors are not always on the perfect height installed, you have sometimes motors on top at the roof or on a very bad places which are not very easy accessible by people to make analysis and maintenance all the time, and maybe they're not visible and you forgot. And the sensor is ensuring that the bearing condition is good, the cooling, the greasing. So if the bearing vibration is starting to exceed the allowed values, then the smart sensor is pushing you a notification over the smartphone, email, or however you want. And then you can see, okay, the motor needs to be regrazed, or the alignment of the motor is not good, and such stuff. Also, the operating hours, the starts, and everything is counted and shown in our dashboard. As you can see here on this page, there are many motors connected to this dashboard, and then you can easily go to the motor which has a warning, which is indicated, or the alert, which is indicated as an orange sign. Then you can go there, and then you can see where the motor is located, what is happening there. Is the vibration too high? Is the temperature too high? And you can react in a very proactive way and avoiding a failure or a breakdown in advance. And once a year you can do an excessive measurements. Then the sensor is generating a report which indicates what has happened over the year, how is the general condition, and what is the assumed lifetime of the bearings and other stuff, so that you can plan and schedule your maintenance in a predictive and more accurate way without the traditional maintenance schedules. So here we can see how it looks like. There are the vibrations. We can see here the overall vibrations, skin temperature, bearing condition. So your motors are always checked and you are aware about their situation. And then you can see also the severity and the urgency of these kind of cases which can pop up. So we can see here, this is maybe a milling motor or whatever. So we see that we have some alerts, but those are not very problematic or very severe or dangerous. So the more the motor is in the orange or red zone, the faster the action needs to be, and the intervention is required. So we are coming to the topic of energy efficiency. Why are motors crucial for energy efficiency? So motor-driven applications are accountable for 47% of the total electrical energy consumption. And these figures that we see here are very huge, and this is giving us an easy handle to reduce the energy consumption, improve the sustainability, and the whole overall cost of the production plant. We can see that 86% of the motors are between sizes of 0.75 kilowatt to 375 kilowatt input power, and this is the range where the whole regulation are designed for and everything. And how this cost, or what is the total lifetime cost of a motor, as we can see here, compared to the whole lifetime cost of a motor which is running 20 years as an example. The purchasing cost, or the initial cost to buy the motor, is only 5% compared to the very huge amount of 92% energy consumptions during his lifetime. If the motor runs all the time, has a huge power, 200, 300 kilowatt, you can calculate by yourself how much of energy he will use and how much of cost this will generate. So if by tackling this 92%, this gives us a huge opportunity to improve and save money. So how do we save energy and money with electrical motors? I have divided that in 3 steps. Number 3, or let's begin with the 1. The most important step, or the most obvious one, is to use the most efficient motors. So if you're buying a motor already, so you have to do an investment, why not buying the most efficient motor at this stage? Because the additional cost of this motor is maybe very low, but the savings he can generate is very high. We can see that in the following slides. The number 2, use VFD control where the process is requiring it. So if you have a fan which doesn't have to operate always on the maximum power, this gives you the optimal possibility to reduce power consumption and improve your process regulation, as with a VFD drive as an example. And the point 3 is ensure optimal operation of the motors. Broken motors, I mean, if the motor is running with a broken gearbox, with a broken bearing or bad cooling and everything, they are causing a lot of additional losses. And if the motor breaks, also the production is lost in this kind of a particular application. What we can see here are the efficiency classes. We are speaking about IE class, I1, I2, I3, and I4. We have also I5 motors at ABB, which are synchronous reluctance motors. They have no rotor losses. It's an old technology which exists more than 50 years, but ABB has done a redesign of it and improved it so that the motors are very, very efficient. What is the step or the difference between one I class and the next I class? Always 20% less energy consumption. So not less energy consumption, excuse me, it's 20% less losses. So if we have I1 with 95% energy loss, or the bandwidth is 20% less losses for the I2, and this goes on for I3 and I4. And as you can see, the losses are always lower and lower, and then the bandwidths are also more narrow at the higher the energy efficiency of the motor is. As we can see here, as an example, some energy efficiency regulations for the I1, I2, I3, and I4 motors. So here is an example by using the most efficient motor which is available, or as an example, I1 compared to an I4 motor. So this is an application with a 132 kilowatt motor running 8,700 hours a year at 90% load, and the kilowatt hour price is 12 cents. So the I1 motor, because the bigger the motor, the higher the efficiency is. We can see here the energy efficiency difference, and we can see also the annually power consumption, and by the difference what we see here of the high efficient motor, we can save annually 3,990 euros as an example with this kilowatt hour price. So the return on investment is quite fast. If you compare, you have to spend a certain amount for an I1 motor. It's, as an example, 10,000 euros or dollars, and the I4 motors is 20 or 30% more expensive. Then this 20 or 30% which you are spending more for the more efficient motor are returned in a very, very short period of time, in 1 or 2 years. And here we have an example for the step 2, the blower. It's a blower with the same power that we had before, 132 kilowatt. It's running 8,700 hours per year. So the process is not requiring all the time the same airflow. And if we reduce the airflow by 60%, then we can see here the different regulation methods: throttling, cyclic control, which has linearity, and the VST. And the VST, because we have a blower or a pump, they have quadratic torque curves, and the power is increasing very much by the speed and everything. So we see here an enormous potential of energy savings. And if you have such application where you have blowers which are running direct online, then this gives a perfect opportunity to save costs, as an example. So in this case, the total annual savings would be 65,000 euros in energy, because we can see here the power is going from 72% down to 30% of the output power, which we use with the VFD control. We have here fact sheets and stuff where we have used. It was for a milling application with Bühler together here in Switzerland with a synchronous I5, a synchronous reluctance motor with a 37 kilowatt motor. they could save 50% of the energy costs for this type of blower. I'm sure that everybody has such blowers in the grain milling industry. The success story is here. It's not a new one. This technology exists quite a long time, but it's very important that everybody's aware that there are huge potentials for energy savings around. And the part 3, use smart sensors also to increase the energy efficiency or reduce power consumptions. These sensors really improve the safety of your application, reduce downtime, they can save energy and optimize your investment and the power plant, production. So I'm at the end of my presentation regarding with the 3 steps. Thank you very much for your patience and time, and I'm here now for your questions.
Thank you, Aleksander. It was a really nice and amazing presentation with a lot of information. I would like to ask our audience if they have any question, please feel free to ask them and interact with Mr. Aleksander. From my side, I have one question. What are the most common failure resulting of motor breakdown from your experience?
So the most common motor breakdown failures, or the bearings are the parts which has the highest breakdown possibility, and good lubrication, proper engineering, and temperatures and everything needs to be good to ensure a long and good bearing lifetime. I mean, 90% or 80% of the motor breakdowns are caused by the bearings.
Okay. And when we talk about the motor replacements, how you suggest to go to get the best benefit of a motor replacement? I mean,
as an example, there are many different suppliers and possibilities. If you have a motor there which needs to be replaced, then it's very important that you have a partner which has the proper application knowledge in the grain milling industry. As an example, Bühler or ABB, which can support you in the many difficult topics by selecting the proper motor. If you are only driven by the price, then you are maybe ending up paying 2 or 3 times the same initial price for the motor, because the motor lifetime is not what you can expect for a proper designed good quality motor, as an example. So you are always, if you don't have the application knowledge, as an example, if you're not familiar with that, go to Bühler or to ABB and ask for the application knowledge, how to replace and what is the right motor for this particular application, and go for the most efficient motor, because this will save you money for the long run.
Thank you very much. That's fair enough. How long is, when we talk about shelf life of a motor? It depends on the atmosphere, of course. It depends on the temperature. It depends a lot of factors. But in average, how many years you think that the motor should be in operation before we take it out and we replace with the new motor with higher class?
Good. If the motor is fine and you don't have to replace it, I mean, motors are quite robust and heavy components which can last very long. So if they are properly maintained, I have seen motors which have been in operation for 50, 60 years, as an example. Then they have a proper maintenance every year. The bearings are replaced and everything. And if you have a broken bearing, then do not wait until the bearing has damaged other parts of the motor. then you should keep the damage as small as possible and replace the motor or replace the bearing. It depends also which size has the motor. If you have a huge 1 megawatt motor, then you can do quite a lot of maintenance before and replacements and reparations before it's necessary to buy a new one. But if you have a small motor like 5.5 kilowatt or whatever for a blower or a fan, and the bearing is broken and your repair shop is very far away, then it makes sometimes more sense to buy the most efficient motor and replace the whole motor and recycle the material. It's more economic in that particular case. So it depends on the motor and the application and on many things. We know that motors in dryers and very different demanding situations, they don't last as long as other motors.
Very good. We have a great question from Antonio. Thank you, Antonio. How we can measure the IAE level after rewinding a motor, ABB motor, specifically?
This is a very good question.
Yes.
Rewinding motors is, I mean, there are guidances in the norm how to measure motor efficiency. So this is regulated by the organs which are designing the regulation, and there are also factors and methods how you can measure such motors. But then you need to have a proper test bench and how to say optimal loads and stuff like that. So you have to be able to adjust the load properly and everything. So this is quite a difficult situation, and it doesn't make too much. It's difficult to do it in every time, and it's very expensive, and does not make sense to do it all the time when you're rewinding a motor. But usually we have made also some measurements at ABB by our partners which have rewinded the motor. But it's important that the amount of copper and the windings and everything is almost similar, and that you can create the same winding density inside of the motors. This is very difficult because not everybody has the same tools, but this is very important that you use good quality copper and a huge winding density, and then you can measure it also on the application. As an example, if you measure the motor before the rewinding, the efficiency on a certain application point, then you can measure it back again on the same application and make a comparison. This is maybe the most practical and easy way, but otherwise, to make it proper according to the standard, you need an expensive test bench.
Mm-hmm. Mm-hmm. We have another question from do you recommend motor replacement or motor refurbishing?
Yeah, this is very particular for each situation. So if you have very huge, it depends also on the breakdown of the motor. If only the bearings are broken and the motor is a quite huge one, then a bearing replacement by an authorized or good service workshop is much faster, because you cannot buy a huge motor which is suiting perfectly for your application. They have a delivery time, lead time, and everything. So in many cases, a refurbishment is a very good solution to get your plant up and running again without huge efforts or something like that. So bearings can always be replaced. This is quite easy. If you have a winding issue, then you have always to check what is the delivery time of the new motor, what is the cost of the refurbishment, what is the cost of the new motor, what are the savings I can get with a new motor over the plant operation for this particular application. Maybe you are buying a new machine, and this machine has only to last 3 more years. Then all those kind of considerations needs to be taken in account, and that's why you can talk always to a specialist.
Absolutely, absolutely. We have another question from Naga Foods. How many times a motor can be rewind?
Yeah, this is something I have never thought about.
Yes.
But basically, the winding is a static part, and if you have a proper insulation material and the stator is built of metal, so there is no much mechanical stress, so you can rewind the motor many times if necessary. But usually, also for huge motors, I see that it happens maybe one or twice in the lifetime, because a winding should not break down very fast. I mean, if you have a winding failure, then you have most probably something which is wrong. So then you have to consider to make some changes and in the application, and to see why the winding has failed. Maybe due to temperature, maybe the motor is too small, maybe such things. So and then you can rewind it. But if the motor is still too small, then the winding will break again because it will be overheated or something like that. So there are measures to prevent winding failures. So this should not happen very often. Basically, yeah, one per lifetime maybe of the motor.
Okay. Another question from my side: when we do rewind motor, the energy, he will absorb more energy than the original motor coming from the factory. Is it due to the proper rewinding, or the type of bearing, or the human errors, or what exactly? Or it should not happen? Just to understand.
I mean, if you have an old motor as an example, which has been produced 10 years ago or 15, 20 years ago, then if you have a proper workshop, I know of cases which have happened that the new good quality copper and the winding possibilities of the service shop have maybe done a very good work, and the motor has the same efficiency or maybe better one than the old low efficiency motor. But if you are going to the very high efficiency requirements, i4 as an example, with 96% efficiency level or something like that, then the stator winding and the rotor and the air gap, everything is very made to the last bit of how to say, it's very precise and it's a fit together. So then it's most probably, if you have an i4 motor and you're going to rewind it, that you will lose maybe 1 or 2% or 3-4%. It depends how good the rewinding shop is. So not everybody's using the same copper, the same stuff, and it's a very case-by-case issue. So if you have very professional rewinding workshops which can do the same quality, but there are also, as everywhere, bad quality materials and shops. So then you have a motor which has not the same output power and lower efficiency.
Very good. We still have 2 questions in the pipeline. Maybe we can ask them quickly, and for others, please get in touch with Mr. Aleksander. You can find his email and you can ask him if you have further questions. So the first question from Ahmed. Hello, Ahmed. Thank you very much for the question. Is there an ideal motor temperature as a general, or it will vary from motor to another? Does the manufacturer consider which region the motor will be shipped? I know, Ahmed, this question is coming from, because Ahmed is in Dubai. So, you know, the temperature in Dubai is very high. It's normally can reach 48 degrees Celsius. So any insights for this point?
Yes, basically the standard motors from ABB, they are designed they can operate without any derating until 40 degrees of Celsius. And then if you have as an example, an application where you need 100 kilowatt output power with 48 degrees ambient temperature, then you have to use this kind of additional ambient temperature as a derating factor for the motor, because the motor winding operates until a certain temperature level. And the high efficiency, as an example, if you have an i3 or i4 motor, they are very high efficient, cool motor which operate on a very cool level. So they're not heating up very much. So then you have some, I mean, easily if you want to go straight away and easy, you can use 8% derating factor for this 8 Celsius, 8 grade Celsius additional temperature, or you can speak to your motor specialist like ABB. Then they can see what are the temperature reserves for those motors. Like i4 motors, they are operating very cool because they need to have less losses, less temperature losses. So they're not using the whole temperature possibilities of a motor. So this is, and then there are motor lines, as an example, which are built for certain areas. We have an example, India specific motors, and they are designed by factory by default for 50 degrees or something like that. So, but usually the normal products are always designed for 40 degrees ambient temperature until 1000 meters above sea level. This is the same if you have a motor for Mexico or at 3000 meters above sea level, then you have also to calculate temperature derating factor for those operations.
Very good. Thank you very much, Aleksander. Due to time, we take the last question is from Naga Foods. If motor runs with VFD, what is the acceptable hertz to be operated in minimum and maximum?
If this depends on the motor and the load. If you have a self-ventilated motor, then this motor has a certain temperature curve with low speed. So it cannot be loaded 100% at low speed because the cooling is not sufficient. In that case, if you want to have very low operation of the motor with very low speed, you have to add like forced ventilation or water cooling or such stuff. But there are no limits. The motor can basically, if you have a 50 hertz motor, you cannot operate the motor with 20,000 RPM or 300 hertz or something like that. There are certain operation points, but you can operate it from, I would say, 20% of the nominal speed until 150% of the nominal speed. But then you need to calculate a little bit the load and the temperature of the motor and make a proper dimensioning of the system.
But even if we go higher than the nominal speed, we should always be in the nominal range of amps that he's absorbing. Should not go up, otherwise we will damage the inside of the motor.
Exactly. So this is quite a rough and a good statement, which I can agree. If you have continuous torque, then you cannot go above the nominal speed. As an example, if the nominal torque and the load torque of the application is, but if you have some margin, then with the same torque, the current is increasing for the field weakening. It's called field weakening operation. But you can go up, but the load needs to be reduced in that kind of application because the current is increasing. We are not able to increase the voltage anymore, so the current needs to be increased, and this is increasing the temperature, and this has to be limited or very proper dimensioned.
Thank you very much.